Hello. Hi, everybody. Welcome. My name is Heath. I'm the Adult Services Librarian here. So on behalf of the library, good evening. And I just want to really quickly remind everybody to please silence or turn off your cell phones to avoid any interruptions during tonight's program. And I would also like to extend our thanks to Norwood Community Media for coming and allowing us to bring this program to a wider audience tonight. Without further ado, I'm going to pass it over. Please welcome me in joining our presenter, Joe.
Yeah.
Thank you so much.
Of course, yeah. All right. Thank you. All right. All right, so I don't think I need a microphone. I'm loud enough. All right, so I think I know about 80% of you who are in the audience tonight, but I'll introduce myself. My name is Joe Deli Carpini. I'm a meteorologist with the National Weather Service down in Norton. We're the Boston office. My official title is Science and Operations Officer, which is a really fancy term saying I'm the manager of the science and the training program for the office, so I do a lot of that. My wife and I have been in Norwood with our two kids, my wife Kelly in the back and Jason on the side, and my daughter Jessica, who's not here. Kelly and I moved to Norwood in 1996 from New York. We were going to stay here 2 or 3 years and then head back to New York, but it was too expensive. So we ended up loving the town here. We stayed here, raised our kids here, and we're here for the long haul. So I've been with the National Weather Service in Boston since the same time. Before that, I spent 5 years in Binghamton, New York. In college, I was a student trainee when the office was at Logan Airport, so I kind of came back to the area, liked it so much. Great area, lots to forecast, as you know, very hard to forecast too. But I thought tonight I'd just go through a little bit about the Weather Service. A lot of people don't really know kind of who we are. Everyone always says, are you on TV? I'm like, no, I'm not on TV. Unless something bad happens, then you might see me being interviewed on the news, like with the tornadoes we had last summer. And then the second part, we'll talk a little bit about the winter, kind of where we are, which I think we all know. It's warm and not a lot of snow, and kind of where we're going to go for maybe the next month or so before winter finally closes out. So to start, the National Weather Service is a federal agency, so I'm a federal government employee. We are under the Department of Commerce and also under NOAA, which is the National Oceanic and Atmospheric Administration. We are the source for all the official warnings that you hear about weather. Tornado warnings, flood warnings, they all come from us. When we interrupt your TV program, that's us. But we're essentially part of the federal government, and yeah, when there's a shutdown, we work and get paid later, but that's okay. So the National Weather Service, starting on a big level, we have a lot of national centers. I think many of you probably know about the National Hurricane Center, maybe the Storm Prediction Center, which is out in Norman, Oklahoma, the Weather Prediction Center, which is down in College Park, Maryland. Those are kind of the most well-known of our national centers. The newest one is down in Tuscaloosa, Alabama, which is called the National Water Center, and I'll talk a little bit about what they do in a minute, but they're working on flood inundation mapping for the entire country. So you guys have probably heard about flooding on the Neponset River, and it says the stage is this. Eventually, there will be maps available showing you down to the neighborhood level what's going to flood in real time. So really exciting. And they're just getting started with that now. The pilot areas in the Northeast are in upstate New York and in western parts of Massachusetts and Connecticut. So I'll get to a little bit more of that in a minute. But this is who they work with, the River Forecast Centers. These are regional offices. There's 13 of them. And they provide us forecasts for the larger rivers, also flood guidance to support our operations. So the Northeast River Forecast Center is co-located in our office in Norton, so we're one of 13 that are kind of these double offices. But they also, as I mentioned, work with the National Water Center to implement these flood inundation maps, and that'll be ongoing from now through about 2028. Knock on wood that the budgets allow that. So it'll be for the next 5 years or so. We'll be working on those. You'll be able to see those kind of in real time, like flooding's coming. Here's what's going to flood. Here are the streets. So it's kind of neat stuff. Another one unit that we have, these are called Center Weather Service units. So across the country, there's a number of air route traffic control centers that the FAA operates, and each one of them has 4 meteorologists from the Weather Service who are embedded there and do the work. The Boston CWSU, as it's called, is up in Nashua, New Hampshire. I also oversee their staff for training, and I get to work shifts up there sometimes, which is a lot of fun because they tell you when you're wrong right away if the planes are starting to circle around. But it's a different world. But they work directly with the FAA. They're briefing the controllers, traffic management units. So for the Boston Center, which is mostly covering a lot of New England, they average of about 5,000 flights in and out of their airspace. A lot of the ones coming to and from Europe pass through their airspace. They also deal with Boston's Logan Airport, also with some of the New York Metro airports, because when it gets busy down there, they send the planes up here, so they have to manage that air traffic. They mainly deal with en route concerns, so it's things when you're in flight, icing, turbulence, even thunderstorms in the summertime. So they brief what's called the TRACON, which is the Terminal Radar Approach Control, and I'll show a graphic of what all this means in a minute. And Logan Airport, that's their biggest customer. But they also work with us on aviation forecast to ensure we're sending the same message, because the FAA doesn't like it when they're telling them one thing and we're saying another. So they don't like that very much. So this is really, for those of you who may be flown in and out of Logan, this is kind of a quick diagram of how it works. So when you're on the ground at the gate, getting on your plane, anything at the airport is under the direction of the Weather Forecast Office, and I'll show a little bit more about what we do. We have a forecast specifically for the airport that manages the airport operations. Once you take off, you go under the control of the TRACON, as I mentioned. They get you in and out kind of the approach to the airport. And then you're handed off to the center where you're in your cruising altitude. You're going from center to center. So if you're going from here to Los Angeles, you're going from Boston Center probably to Cleveland Center to Chicago Center, over toward Denver and Salt Lake and eventually LA. So you're handed off. You've got someone with you on all phases of the flight there. That's for the Center Weather Service unit and also the Aviation Weather Center, which is the national center. So they're kind of taking care of the weather during that phase. And then when you land back at your destination airport, you're back under the Weather Forecast Office. So each phase of the flight has some sort of weather service support along the way. So getting to our forecast offices, here's our puzzle map of every office throughout the country. So we have forecast offices throughout the continental United States, Alaska, Hawaii, all the territories, Puerto Rico, Guam, even some of the Pacific Islands, there's support there. So it's a big puzzle piece, but you can see if we zoom up a little bit closer on New England, the Boston forecast area is all of Massachusetts except for Berkshire County. That's handled by the Albany, New York office. We have all of Rhode Island, including Block Island, and also North Central and Northeast Connecticut. But our office handles the three state capitals, Boston, Providence, and Hartford. And with the high population as well. I think we've got over 8 million people in our area, which gets bigger in the summertime because we have the Cape and the Islands. So our office in Norton, we moved there just about, 6 years ago now, March 2018. It's a brand new facility. Formerly, we were located in Taunton. You may have heard about the Taunton office, literally a half mile on the other side of the building. The building got into a little bit of disrepair, so the government said it would be more cost-effective to the taxpayers to build our own facility and manage it ourselves through GSA. So that's what it is. Prior to 1993, the office was in Boston. From 1871, it was at the old State House. Then it was downtown, the post office, a number of hotels. Went to Logan Airport in 1936 and stayed there until 1993. So always have some sort of presence in Boston, although we're outside of the city now. 26 employees full-time. Most of them are meteorologists. We have electronics technicians who work on our equipment, radar, computer systems. If you have anyone have a NOAA weather radio? Oh, yeah. So the transmitters for that, of course you do. We have 5 different transmitters. And we have some administrative support too, things like budget, paying the bills to keep the lights on, that sort of thing. But our primary duty is really just monitoring for hazardous weather. That's why we're there 24/7. Thunderstorms can occur at night. We have snowstorms coming in the middle of the night. So any type of hazardous weather, that's why we're there. Secondary is actually the forecast, believe it or not. But that's the thing we do most often. We cover out to 7 days. We don't really go beyond that, but we give specific forecasts out to 7 days. Also observations. We have a number of automated airport stations. That's where you see the weather from the airports. We also have our longer-term climate sites. We have volunteer observers, cooperative observers, spotters, that sort of thing. And as I mentioned, the Northeast River Forecast Center is located here. On the lower right, you can see our typical workstation. We have a Linux-based workstation that we use. It's called AWIPS, and we get all of our data in and out through satellite transmission. Works pretty well. And we also have PC systems too. We can look at weather online, like many of you do, I'm sure. We look at a lot of the online weather sites too, and also things like social media and different communications for the internet. So a few of our forecasts, in addition to the day-to-day, sunny and a high near 30, the aviation forecast, as I talked about, this is where we handle things for, say, Logan Airport, but we also do forecasts for 8 other airports in New England, kind of the busier ones. Most notably is Nantucket, which becomes the second busiest in New England in the summertime, believe it or not, with all the VIP traffic, shall we say. But Boston is our main focus. The coded forecast you see there in the middle is what we issue. It's called a TAF. It's a Terminal Aerodrome Forecast. It's kind of an international standard for forecasts. So the forecast that we issue is the same kind of language as they use in Europe, Asia, all over the world. Pilots, it's a standard language for pilots. The first group, if you look across, is a wind direction. So the first group at 313 G21 KT. That's a wind from 300 northwest, 13 knots gusting to 21 knots. Next is a visibility, so +6 miles, so that's good visibility. If there's any weather, that goes next. That's a light rain shower, and then add 2 zeros to the cloud height, and that will tell you the clouds. So it's 3,500 feet at overcast. So what this is used at the airport is first for runway selection based on the wind. You have to take off and land into the wind for the aircraft. So knowing what runway gets used tells them how many aircraft they can get in and out per hour. When the weather is good, there's no problems. When the weather gets bad, that's when they have to reduce the number of aircraft coming in and out, and that's when you get your weather delays. So for Boston, the best configuration is when they have an northeast wind. They can run what they call the fours. They have 2 parallel runways, 4 left. And they'll actually come over Norwood. You'll see them coming in to land. They can get 60 aircraft in every hour, so 1 a minute in good weather. If there's bad weather, they cut that maybe in half. So that's when you start getting, okay, my flight's not taking off on time and things like that. So that's usually the reason. It's the capacity of the airport. Based upon the weather. The other thing we do is for ground operations, airport weather warning. So if there's lightning within 10 miles, we notify them. If there's icing, snow, strong winds, so the people like fueling, you're not going to want to fuel when there's lightning out. The cargo handling thing, baggage handling, things like that. All those folks, this helps protect them and keep them safe too. Other areas, fire weather is another area. It's biggest in the spring and the fall, which is our brush fire season. We do a lot of briefings for prescribed burns, especially on the Cape and the islands. They like to burn a lot of the litter and debris to prevent larger fires in the summertime. So they'll do days where they do what are called prescribed burns. Also things like burning permits, days where you can burn at your house, if you go through the fire department. And then when there's actual brush fires or forest fires, we can provide information as well. In the east, we don't have these big fires like they do out west. But we also have a number of meteorologists in the Weather Service who are called incident meteorologists, and they dispatch to these larger forest fires. A lot of them go out to the west. Some have gone to Australia in the past. We share with other countries too, resources. So that's over hundreds of hours of training to be able to do that. But you actually go on site to the forest fires. And some of the critical weather elements they're interested in: temperature, humidity, wind speed and direction. Something called mixing height, which is how high the smoke can get for dispersion, or we get trapped near the ground. That's always an issue. And then lightning, of course, too. How many sailors do we have in the audience? Any? No? Anyone ridden a boat? There you go. All right. So we do what's called marine forecast. It's not the military. It refers to the wind and wave forecast. So we cover all those colored areas off the Massachusetts and Rhode Island coastline out to about 25 miles. For commercial fishermen, for entities like the Coast Guard. One of our closest friends is the Steamship Authority, a lot of the ferries within Boston Harbor. We provide year-round forecasts. It's busier in the summer with recreational boating, and that's really the intent when we get into the summer weather. But a lot of the year-round, especially fishermen, they go out to George's Bank for days or maybe a week at a time. So they need to know the forecast heading out in and out of port. And New Bedford's actually the second busiest port, I think, on the East Coast for fishing. So it's still a very active port. Gloucester is active as well. Talking about hydrology, I talked about the Neponset River. We also issue daily forecasts and watches and warnings for flooding for the larger rivers in the region. It's kind of a map there on the left. The Neponset's one of them. This was from the other week when we had some minor flooding going on there. The gauge is right down off of Pleasant Street, just a little bit past Dean Street, where the river goes across the road there. But this is a daily forecast point. This is produced from the River Forecast Center. They pass us on the forecast and we kind of package it and ship it out to everybody. Coastal flooding is another big area that we're doing, and we've made a lot of advances in this in the past few years. We've got a portal on the webpage that shows, again, similar to the river forecasts, the different locations. We do a daily forecast for a bunch of coastal tide gauges from the Merrimack River down to the Cape and Islands to the coastal Rhode Island. The thing we're doing now is to start working on the lower right, these inundation maps for flooding. This is the city of Boston at about a 14-foot storm tide, which they had a couple of them in the past couple of storms. So areas like the Seaport District get flooded out, the waterfront gets flooded out. So we work with Boston Emergency Management. We can kind of show them the neighborhoods that are kind of most at risk prior to a storm. And then the other area that we're really emerging is called Decision Support Services, and this is where we get right down with the emergency management community and kind of give them, the information that they need. A lot of it is done through email briefings. Say we have these storms that we've had, we'll issue email briefings to them twice per day. If it's a bigger, higher end storm with maybe it's got snow and wind and coastal flooding, we'll do video briefs now that we're kind of, ever since the pandemic, we got in kind of the video age, which is a good thing. So we'll do video briefings. We also do things over the phone upon request, but we work largely with federal, state partners, even local partners. Foxborough Fire, we do work with Gillette a lot. If there's an event there, we don't forecast for the event, but we forecast for public safety. So go back to the Taylor Swift concert a while ago when it was pouring rain, they were worried about lightning. So we had to keep briefing them about, hey, there's no lightning nearby, or there's lightning within 10 miles. Even for soccer events, Patriots games, things like that. They told us at Gillette there's only 25 days per year where there's not an event happening, whether it's inside or out. I didn't realize that. So we support Foxborough Fire Department in that regard. We also go on site when we're needed for some of the bigger events. So Boston Marathon, we go on site. The 4th of July Esplanade, we go on site. Newport Jazz Festival, we've gone on site. So it's up to the emergency manager. If they want somebody there, we can certainly deploy someone to go and just give them weather, kind of on demand. It's kind of a neat thing. Kind of neat to see how they use the information too. But this is really the area we've expanded in the past 5-10 years, and this is kind of the future for the Weather Service, is really getting embedded with the decision makers and providing them that kind of information. So we also do a lot besides forecasting. I'll just touch on a couple of things here. This is more my realm, science education. So we work a lot with the TV meteorologists, Boston, Providence, Hartford, Springfield. We have a really, really good relationship with all of them. It's a blessing because not every office in the country has that good relationship. They attend a lot of our training sessions, either in person or virtually. We do a few training sessions for the staff throughout the year. We invite them. Or we'll go to them. So recently we've been out to Hartford, NBC, Connecticut, went to their severe weather workshop. I was up the road in Dedham, Boston 25. We did severe weather training for their staff. It's just a great way to maintain strong relationships with them. Anyone ever been to our public webinars online? No, okay. Oh, you'll want to. Okay, we got one Thursday. I'll talk in a minute. We do public webinars periodically. Try and do at least one a month. But we've had over 1,200 people attend in the past year. We found out that UConn, Bridgewater State, and a bunch of high schools actually use the YouTube recordings for part of their science curriculum, which is kind of neat. I didn't know that. And we also do guest lecturing. One of our biggest ones is with the NOAA Corps down at the Coast Guard Academy in New London. We do weather training for their classes twice per year for the officer candidates. We also do Bridgewater State has an aviation weather class that we teach, and URI has an extreme weather course that's a lot of fun. So I go and teach that once or twice per year as well. So it's fun to get out and meet with everybody. On the research front, we do quite a bit of that as well when the weather's quiet, which is nice. UMass Amherst, we recently finished up a study, kind of a quick response survey to hazardous weather. Like if you were in an area that received a flash flood warning, what did you do? So we can get everyone's perception and what actions they took. They're kind of correlating all the research right now, the responses. UMass Boston and Dartmouth, we've been for years working with them, modeling and mapping storm surge flooding. So they're going to be a partner as we start to map storm surge flooding a little bit more. UMass Boston, actually, if you look on the top right, there's a little bit funky looking instrument. That's actually a tide gauge that's above water. It's about 1/10 of the cost of a typical tide gauge that we'd have through the government or the National Ocean Service. They developed it. There's one in Gloucester, there's one in Scituate. So it's a way for us to get tide measurements on a kind of cheaper basis. Hats off to UMass Boston for getting those going. And we're also working with Woods Hole Group to get a bunch of new tide gauges deployed throughout the Cape and Islands. We've got one in Edgartown right now. We just started forecast services for. And there'll be a bunch more. Hyannis is another spot, and actually all the way up the coast, Duxbury and those areas as well. So these low-cost tide gauges are kind of coming online as a better way to get us observations. UConn, we're working on a study to predict power outages from wind gusts and also snow load during winter storms. That's been an ongoing study. It's partially funded by Eversource in Connecticut, but We share information with them, and they share their forecasts with us to help us with our messaging. And Boston University is working with the MBTA. We're working with them also to mitigate flooding and winter weather impacts on public transportation. So, does the T-stop need to be shoveled out or sanded? Is there going to be flooding at the aquarium T-stop? Things like that. So that's another one that's been a multi-year study as well. So just a few of the things that we've done. And some of our relationships as well. I see Jason in the bottom row there. Amateur radio. Anyone amateur radio? We're Skywarn spotters. We have, and I'll talk about those in a second. So we have a great amateur radio community. We've got hundreds of them. They give us real-time reports during storms. The TV meteorologists, as I mentioned. Steamship Authority is a big partner of ours. We provide them with briefings. A lot of times when they cancel service, it's based on our forecasts, and we brief the captains day in and day out also as needed. A place called the Center for Coastal Studies out in Provincetown has helped us with the coastal inundation mapping. They're actually mapping a lot in Cape Cod right now, and we're going to work our way up the coast to Boston. And Blue Hill Observatory, the longest climatological record in North America, going back to 1884. It's right up the road, but they're certainly a great partnership for climate data. So finding weather information, if you haven't been to our website, weather.gov/Boston, easy to remember. If you go to the top at the news headlines, you'll see there's a link right now. We have a webinar Thursday night at 7 o'clock. It'll be similar to this. We're going to talk about the winter so far and kind of where we're going and review some of the past storms in a little more detail. So you're welcome to sign up for that. But also you can get any kind of weather information. You can put your location or zip code anywhere in the country if you're traveling somewhere. Just a wealth of information on our website. And also for those of you on social media, Facebook, Twitter, X, whatever it's called now, and YouTube. Actually, our YouTube channel has all of our past webinars that are recorded. So we have things like Weather 101, severe weather, winter weather, event reviews. There's a wealth of information on there that our staff puts together. So feel free to follow us on any of those. So a lot of people ask, what can I do? There's three nice programs I like to mention. First is Skywarn. You can report storm damage or rain or snow totals. There are training sessions we hold in the spring periodically, and you can look on our website for our schedule when it comes out. You don't have to attend one. You can just go to our webpage. At the bottom, there's a bunch of icons. One says Submit Storm Report, so you can submit a storm report. If you see flooding, if you want to stick a ruler in the snow and say, I got 4 inches of snow, send it to us. That's fine. You're more than welcome. For those of you who want to try an app, there's a thing called MPing. This is from the National Severe Storms Lab, and it's just a way you can send us current weather. So the other day we had rain, snow, everything, right? I was hitting MPing. It's snowing. Oh, it's raining. Oh, it's sleeting. And we can see it at the office. It's awesome. But it also is used by researchers to correlate what the radar is detecting and what's actually falling at the ground. So it's being used for the radar algorithms too. So the more you send stuff in, the more it can be used for research. It's kind of cool. But we definitely look at it too, especially when we get rain, snow lines and things like that. Then the third one is called CocoRoz. It's a little more involved. You have a plastic rain gauge you have to purchase. It's about $30. But once you have your rain gauge, you measure, report every day. You can report 0 if nothing fell. But you report your rain or snow totals every day on a website or mobile app, and we get that data too. The CocoRoz data is not only used like when we send those big reports of the snow listings or rain listings, but we use it for drought assessment too, huge in New England. So every month for Massachusetts, Rhode Island, and Connecticut, we compile a summary of rainfall totals or lack of rainfall totals, and that's used as input into drought declarations. Or for us, flood. This time of year, we're looking at flooding. So the rainfall reports, the more we have, the better data, better assessment we can make. So just 3 easy ways that you can, become involved. We call those citizen science programs. But if you're interested in weather, you're certainly welcome to do 1, 2, or all 3 of them. So, all right, we don't have time. We're good. All right, so let's talk a little bit about winter so far. And I'll leave plenty of time for questions at the end. So this is looking at a graph from Norwood Airport, which is where we have our temperature readings from. The bars are the high and low for each day going from December through about yesterday. So winter in meteorological terms is December, January, February. So we're almost 2/3 done. But for climate purposes, those are the 3 months. So you can see, overall, we're kind of the middle gray tan area. Let me see one point. There we go. This area is kind of the normal. So you can see we've been, mostly above, and those are the record highs and record lows in the red and blue. So, overall, it's been, as you probably know, probably a little bit near or above normal. And, where do we go from here? That's a good question. I took a look back to 1999, so roughly 25 years of temperature data from the airport, which is when the automated station was installed. And this is kind of the trend. So you can see, a lot of zigzags in the curve, but definitely a warming trend over the past, 25 years. So far for this year, December averaged almost 6 degrees above normal. I think remember it's a pretty warm December. January also, not quite as warm, but so far we're about 4 degrees above normal. So, definitely a few shots of colder weather in January, maybe a little bit more toward the normal. But, where we go from here, we'll get to that in a couple of minutes. So our winter precipitation, this is rain and melted snow. Definitely, I don't think it's any surprise, we're above normal. So the green line are all the events that we've had, if I can point to that, there we go. And then the normal is this brown line here. So anywhere above this, we're well above normal. And you can see, going back to December, it was off to the races, starting with that first storm around the 11th and 12th. And we're well above. You can see we're almost, close to 7.5 inches above normal. We've had 15 inches for the winter so far, so really no surprise there. And who would have guessed snowfall is below normal, right? So I'm showing the graph for Boston. It's got a longer term climate record than Norwood does, back to the 1800s. Boston's, as of this morning, had 9.2. Their normal is 23, so we're quite a bit lower than that. Norwood, 12.7. So, people always say, well, Boston, gets maybe less snow, it's on the water. Well, luckily we have a cooperative observer down the street in Walpole. So, we're close enough. We can use Walpole as our example. The Walpole observers had about 13.9 inches. Normal is about 26.5. So we're, a little under half of our average snowfall for the year. So a little bit above last year, but last year was really not much snow at all. So, but definitely well below normal in the snowfall. But remember, we still have a lot of winter left, right? We've got another solid month through February, even into March. And I won't bring up nightmares, but remember early 2015, right? The 6 weeks snow blitz that we had. I'm not saying that's going to happen, but a lot of our snow falls late January, February on a normal winter. So, we still have some time left if you like snow that we can get some. But I do think it will be a below average winter, obviously, because we're so far behind now. Just taking a quick look at some of the past events that really got us going. December 17th, the week before Christmas, we had this storm move up the coast. We had a little under 2.5 inches of rain here. Most of the rain actually fell in Rhode Island. There was a corridor of about 4 to 5 inches there. But we did have some strong winds here, if you remember. Boston gusted over 60 miles per hour. I think the airport here actually gusted to about 60, 67 do we have on there? Yeah, close to that, which is rare. The Norwood Airport, it's down in a bowl. It really doesn't get a lot of wind. So that was a pretty strong, and also on the Cape and Islands too, which is typical for them. But this is a decent storm. A lot of river flooding, especially down in Rhode Island, coastal flooding as well from that storm. But we're getting a warm storm. January 6th and 7th, our biggest snow of the year. Imagine that, 6.3 inches. This was a storm that stayed just off the coast, so we were on the cold side of it. If you remember, Meteorology 101, around low pressure, the wind always goes counterclockwise. So this is our nor'easter when we get that northeast wind. So you want the storm to go east, just over the water. We stay on the cold side. If it goes to our west in the Great Lakes, forget it. It's rain. Not going to happen. So you can see this was a good snow for the interior, though. The higher elevations did pretty well, over a foot of snow out in Worcester County. But we were just on the edges of the heavier snow with this one, about a little over 6 inches. Then we got warm again. There's your storm going into the Great Lakes. January 9th and 10th, we had about 2 1/3 inches of rain here. Again, Rhode Island, you can see, got pretty hard hit. Easily, 4 or 5 inches of rain down there. There we go. So again, another warm storm, really no snow out of that one. January 13th, following on the heels of that, and not as much rain with this, but only about 1 1/3 inches, and even down in Rhode Island, just close under 3 inches. But the problem was all the rivers were already swollen, some were still in flood, so it didn't really take much more to cause a lot of problems there. And I'm sure those of you who have basement flooding issues, have been not happy this winter. Then we had a little bit of snow, a little colder, January 16th, 3.8 inches of snow, not a huge deal. Again, the low stayed just offshore. There was enough cold air in place to give us a little bit of snow. And January 20th, 29th, our most recent, just 1.1, not much. Again, it was more focused up on the higher elevations. This just didn't have the cold air in place ahead of it. The storm track would have been great for a big snowstorm if we had the cold air. We just didn't have the cold air in place. It's been, upper 30s, 40s. So there's not a lot of cold air for the storm to work with. So that'll bring us into our main point here, El Nino. So how many of you have heard about El Nino this winter? I think a majority, right? Okay, so it's going to continue this winter. This has been a classic strong El Nino winter, not so much snow. You get the lighter snow and ice a lot of times and rain. So this is actually panning out as Mother Nature intends it, which is surprising to me. But El Nino, in a nutshell, it's the warming of the waters off the Pacific coast of South America. The opposite is the cooling, which is La Nina, which was last year. So this year we're in El Nino. And when you have that warming or cooling of the water, there is a connection with the jet stream. There's an ocean atmosphere connection. And then the other thing to mention is we'll continue into spring, and we'll talk about that in a minute. So what does it mean for us during winter? Really not much. Researchers over the years have been trying to say, what does El Nino do in New England? And it's really not much predictability. But we do know the stronger El Ninos tend to favor below average snow and milder winters. We're seeing that now. Notice for a lot of the country, though, there are some correlations. The northern tier of states into Canada tends to be warmer. The Gulf Coast tends to be cooler and wetter. And it's really that southern jet stream, what we call the subtropical jet stream, that really gets going. And that's what gave us all those big storms that we've had in December and January, the rainy storms that come up from the south, loaded with moisture. So that's why we've been seeing the weather that we've been seeing. The other thing to mention too, we know we're in a period of warming temperatures, and we're going to leave politics out of this. We're not going to get into why, but it is warming. And there is a greater frequency of what we call heavy precipitation, so 1 inch per more, the storms that produce 1 inch per more of rain. The other thing, and I bring this up on my own, if you remember the 2000s and 2010s, we got hit with a lot of storms, right? We always have it seemed like every winter, over a foot of snow from one storm. Well, maybe now Mother Nature is balancing things out. The law of averages has to take over too. So I think maybe we're getting into a period of lighter winters after so many years of big snows. That's certainly possible. How much influences El Nino? How much is, the natural cycle? I don't know. But there's got to be something to that. So the forecast for El Nino is to weaken and eventually kind of become neutral or end in the spring. And I've kind of boxed out where we are in the winter here. So this is December, January, February. And anything above this black line is El Nino. You can see we've already peaked, I think. The models are showing it's on its way down. It'll probably dissipate sometime in the spring. And boy, later in the year, we might go back into another La Nina again. So we'll have to see how that works out. But this is one of the climate models too. Kind of shows the same signal that it's definitely in a downward trend and will be ending sometime in the spring. So we can see also looking over the Pacific that it's already kind of started to begin. So top to bottom, these are the sea surface temperature anomalies or difference from normal. So at the top are the earlier from early January. You can see it's still above normal, but less so. There's less of the deeper orange there now. And if we look in the weekly from about over the past month, you can see there's definitely cooling going on in the eastern Pacific, a little bit less so in the central Pacific. So it is weakening. We know that's kind of taking place, which gives us a little more confidence in those forecasts. So the one thing a strong El Nino does is it favors more coastal storms. And these are what we call the Miller type A. It was kind of categorized years ago. The ones that form off the North Carolina coast that kind of reform and come up? Those are Miller Bs, and those can also give us big snows. But these Miller As are really the ones that are loaded with moisture. Most of our stronger winter storms and blizzards come out of the Gulf. So this is what's been favored this year, and this is what we've been seeing this year. All those big rainstorms that have come up, they've come right up out of the Gulf. So they're loaded with moisture, warmth, and this has been really our dominant storm pattern so far. So we'll have to see. It's kind of taking a break right now, and I'll show in a minute, but we'll have to see if this kind of gets going again in the latter part of the winter. So one thing we look at, not so much El Nino on a seasonal basis, but for our weather, it's more transient. So the jet stream changes kind of on week or two at a time, and those things we can predict. We can go out a couple of weeks and kind of see the trends, maybe not specific, but say, okay, it's definitely looking warmer on these days, or looking colder, or looking wetter. So what we do is we use these jet stream kind of patterns. One of them is called the Pacific North American Oscillation. It's this fancy term for what do we call a ridge and a trough. So when it's positive, you have this what's called a ridge or a bump in the jet stream somewhere in the west coast. and then we have a dip or a trough in the east. And this is what brings those storms right up the coastline. It steers them right up. So this is usually good for cold and at least storminess, usually snow. Where we really want to see this ridge is actually over the Rockies, a little bit east of what this is showing, for us to be good here in New England. Now the opposite is called when it's negative. So you have that dip or the trough in the west, and you've got the ridge more in the east. And in that case, that's when we tend to be warm and dry. So last winter, that was really the dominant pattern all winter long. Remember, it was mild and pretty dry. That really was last year. So this year, we started off that way. We've kind of gone into this more positive phase with all the storms coming up the coast, but we just don't have the cold air in place. It's that simple. If we did, we'd be having a lot more snow to talk about. So what are we looking at in the next couple of weeks? This is kind of an animation showing roughly the jet stream pattern. It's going to loop, and I'll point out, let me come up and point out a couple of things. So what we're looking at, there's really two branches. It might be kind of tough to say, but let's start down here. This is looking at the southern jet stream, so I'll let it go through. When it starts, notice all these little bowling balls or these troughs coming across. These are associated with the southern jet stream. That's what we saw during the early part of the winter. A lot of these came up the coast, but right now, look where they're going. See how they're going off the coast and staying south? It's kind of suppressed. That's because we're being dominated now by the northern jet stream. This has been way up in Canada and really not a factor us for all. Now it's actually giving us a little bit more to deal with. So you see these little troughs come across. Each of them's got a little bit of cold air, a little bit of light rain, maybe a little light snow. What we just had was a good example of that. But notice way up at the top, you see the big circular feature there? How many heard of the polar vortex? That's what it is, okay? It's always there. It's there in June, it's there in December. It's not anything magical like the media would have you say. But notice how far north it is. And really, for us to get a good shot of cold, that circulation has to come down here. And this model, at least through the next few weeks, not really showing that. So to me, this pattern says, it's going to be a little quieter. We're going to suppress the storms with that really amped up southern jet stream down here. So the southeast, I think, will be quite wet over the next week or two. We're kind of left a little bit high and dry, which is probably good. Just calm down a little bit. Temperatures looking at this pattern, we might have a few days. That's a little warmth coming through later this week. Maybe a little bit above normal, getting into the 40s a few days. Mostly, I think we're going to be kind of near normal, which is now upper 30s, and then we'll start getting back into the low 40s as we get more into February. But really, the pattern's kind of relaxing for the time being. I always say, and we say at work, Mother Nature's recharging. So it'll come back. Does it come back at middle of February, late February, early March? We're going to have a spring where it's going to be, again. I'm not really sure. But at some point, this is gonna start to take over again. And, we could get stormy. And it's just a question. We can get some big storms in these patterns too. If the cold air is timed just right, we'll get a decent snowstorm. So it's not, off the table. It's a low chance, I think, but you can't completely ignore it either. So anyway, that's how it's kind of looking, just kind of looking at the crystal ball in the next couple of weeks. If we go longer range, these are the Climate Prediction Center outlooks. I'm sure some of you are familiar with that. A little bit of a warming trend showing up, especially more toward the Great Lakes, but we may get into that here as we get into early February. But definitely you can see the drier signal here on the East Coast and a little bit wetter into the Southwest as some of those, that southern jet stream starts to get them a little bit more coming off the Pacific. And then mid to late February, really not a sign either way. Is it going to be warmer or colder than normal? But there's still that dry signal there showing up here in New England. So notice it's a little bit wetter along the Gulf Coast and the Southwest. So that's that southern, storm track again, but probably staying, suppressed and not really getting up here again. And then just to show into the spring, our seasonal outlook, pretty good odds of above average temperatures for March, April, and May, but that's over a 90-day period. So it doesn't mean you can't be a little cold in there too. And really there's no signal saying we're going to be wet or dry. But you can see the Gulf Coast, still a signal for above average, which tells me that it's still going to be a pretty active southern jet stream down there. And it's just a matter, can we get the storms that come up the coast, or do they, kind of pass out to sea? So we'll see. But in summary, our winter so far has been kind of warmer and wetter than normal, below normal snowfall. The pattern has definitely been dominated by the strong El Nino, with the active southern jet stream, a lot of East Coast storms. And if that cold air is in place, we can get big snowstorms out of this. That's not, that's not out of the question. So really now into next month is when we receive most of our snow each year. So we're kind of getting into that window. But it does look like a drier, quieter pattern for the early part of the month with near, maybe slightly above normal temperatures. And then the question is, do we turn cold and stormy later in February and March? We'll see. And that's from the 2015 snow blitz. I'm sure you remember the snowbanks 5-6 feet high. Yeah. So I don't know if we're going to see that. Just to finish up, always a good reminder to have a plan, whether it's, winter storm season, hurricane season, whatever, floods, if you're in an area that is prone to flooding. You can go on our webpage or go to weather.gov/safety/winter, and you can find a lot of great tips from FEMA there. And always have a disaster kit too. I always say, we're talking winter weather, but hurricanes, we are way, way overdue. I'll just give a quick plug for the hurricane season. Last landfalling hurricane, everyone know what it was in New England? Bob, 1991. And how about the last major, Cat 3 or higher?
1954.
Yes, Carol, 1954. So we are way overdue, right? We know the hurricane seasons are getting more active. It's just a question of the weather pattern that's in place, whether they come make landfall or move out to sea. Fortunately, a lot of them have been out to sea, but we're overdue. So, if we ever get into a situation for hurricanes, make sure you have a kit where you have supplies for a few days. And Norwood's great with power, right?
Yeah.
But if we have even a low-end hurricane come through, there's so many trees and other things, infrastructure that that can be damaged. So just be prepared. I'll leave it at that. So anyway, thank you. I'm going to leave plenty of time for questions here. If you want to, you can write down my email address. It's a long email address, but always happy to to answer questions there. But certainly we have plenty of time now for questions here. So happy to take those now. Anybody? Yeah.
What's this with Norwood all the time? Maybe it's just me because I live here, but you always see the temperature.
Yeah.
It looks like it's, 5 degrees and everywhere else at 10.
Yeah.
And it looks like it's 101 or 99. And is it because of the Neponset Valley?
It's the airport. Yeah. So the airport is located literally in the lowest part of the town. So right in the river. So yeah, at night, we have a clear night with light winds. We call it radiational cooling. The air just goes up. The low spots are going to be the coldest. So yeah, we live up by the tree streets, and I'm usually 5 to 6 degrees warmer than the airport on a night like that. Same opposite in the summertime. It's going to be hotter there than it will be in other areas of the town. So yeah, not the best place for temperature readings, but the weather station is at airports because they support the airport operations. That's why they're there. So yep, but you're right. You can always add 5 degrees at night. Yep.
What exactly is the polar vortex?
So the polar vortex, let me go back. Yeah, I'll show you. It's really it's what's called a semi-permanent low pressure area. And this is just North America. So there's actually more than one. If you were to look at a top-down map of the Northern Hemisphere, you'd see a number of these they're called polar vortices, plural, but they're always there. So they're there in the summer and the winter. In the winter, they become more noticeable because they dip down to lower latitudes. But when you hear about cold outbreaks in maybe Europe or in Asia, it's usually a piece of that is swinging down. So remember last February, we had that really, really cold shot of weather. It was below zero for like one day. A piece of that actually dipped down across the Northeast and was right over us. So that's really, really cold air, Arctic air that comes down. But it's always been there. The media picked up on it a few years ago, and it's like, oh my God, the polar vortex. I'm like,
It's a low pressure?
it's just a low pressure area around the North Pole.
Okay, it's
Yeah.
generally in the same location?
Yeah.
Year after year?
Yeah. And you'll see maybe 2 or 3 of them at a time circling around the pole. And just, like a rope, if I was to whip a rope, you'd see different, patterns emerge. That's kind of how the jet stream works too. It's just very transient. It moves around a lot. And when we get one of these, pieces coming over us, that's when it gets cold. But it's always there. I could show you a weather map in July and say, look, there it is, the polar vortex. Yeah.
How long have they known about it?
Oh, a long time.
Like hundreds of years?
Pretty much since modern forecasting. I would say maybe the 50s is really when the advent of modern forecasting. Like the jet stream wasn't discovered until World War II by the aircraft. That's why it's called the jet stream. So yeah, more recent, but it's been there as long as Earth has been around. So yeah.
So if you saw some old, you're watching something,
Yeah.
in the 1880s, they had unbelievable cold weather.
It could be correlated to that. Sure. Yeah. Yep. Yeah. Yeah. Good, Steve.
Joe, Besides the temperature from Norwood Airport, did they do calculations on precipitation? Do they measure precipitation?
Yeah, there's an
down there?
so that's an automated station. So it's okay. It doesn't do well like on days like yesterday when it's like snow falling. If it's near freezing, it does okay, but like in a good snowstorm, it's 25 degrees. It's not going to melt the snow. It's got actually a heated rain gauge. It just doesn't do a good job. The other time is when there's really heavy rain, like 2020 when Norwood Hospital flooded. It didn't do a good job then because it has a little bucket that has a tipping mechanism, and it couldn't keep up. So that's why, Steve, we have Coco Ras, right?
Yeah.
I have one of those plastic gauges at my house. They're a lot more accurate, and that's why we use those in addition to the airport sites. So it'll underreport 10, 20% sometimes. Yeah. But winter is a known problem with them. But again, they weren't designed for like weather, climate. It was designed for airports. So that's kind of what we're stuck with. Yeah. Yeah.
Could you speak specifically, if you know, to like what the city of Norwood is doing for climate or weather mitigation or preparedness?
It's a little outside my realm. Probably would have to talk to Tony Mizuko, but I know they are looking at building, not building in certain areas or building, to code in flood-prone areas. But that's a little bit outside of my realm, unfortunately. You'd have to speak with the town. Yeah. Yeah.
Are you, interact with the Mount Washington Observatory? Do you guys work with
Yeah, so they're in New Hampshire, which is under the Portland, Maine office. So they do interact with them. They send them weather observations. Yeah, but yeah, they are a climate site too. So they do report, and I'm sure you've seen the video from up there too. They send people months at a time in the winter to kind of
So follow up on
spry
that.
weather.
Have you
Yeah,
been up to the summit in the winter?
not Mount Washington.
No.
I've been to Blue Hill, but no, I haven't been up there. No, that'd be kind of fun.
Yeah.
Someday. That's on the list, Callie. Yeah. Oh, go ahead. Yeah. Yeah. So those are just they're just like global. We call global patterns. Just kind of Earth's natural cycles. There are cycles where it's warm, maybe every 5-10 years. It's cold every so often. It's just part of Earth. It's kind of hard to explain otherwise.
Where did they originate?
Where did?
Or where did they start? They originate the,
Oh, I'll show you. It's in the, so it's really in the Pacific. So we'll start where they measure, they more deal with this zone here, Central Eastern Pacific is where they monitor, and they get the temperature data from largely from satellite. But also there's some ocean buoys out there that measure as well. But the importance is any changes in the ocean temperature anywhere in the globe, there's a connection with the atmosphere. And so that's kind of how we've learned over the years, well, when this happens, we tend to see this over North America, or we see this over Europe. It's kind of a correlations working that way. But it's one of Earth's natural cycles. Kind of.
travel to the east, do they?
It can, yeah. It'll gradually sometimes expand to the east and then retreat westward. Yeah, yeah. And you can see now it's starting to retreat a little bit. Yeah, yeah, yeah.
Do you have any insight on the upcoming eclipse that's in April? On the forecasting, I've been reading a lot about forecasts of how to plan where to go.
Yeah.
Have you looked into any of that since New England is on the...
Yeah, so April's not a great time in the totality path east of the Great Lakes. I can tell you that from personally having lived there. I'm hoping, at this point, there's not much you can say. It's just too early. Forecasting-wise, probably won't have an idea for about a couple of weeks ahead in general terms. It can be pretty difficult. But yeah, for here, I mean, it's partial, so we're hoping we can see maybe something. But yeah, that far out, that's just too far out to even try and take a guess. So unfortunately, I wish I had a better answer. But yeah, I mean, the springtime in that region tends to be cloudy. But maybe we'll luck out and it'll be nice and clear. But yeah, we won't know more than probably a couple weeks ahead with any sense of accuracy, unfortunately. Yeah. Yeah.
Yeah. How do you deal with, or do you share information with private weather vendors? Weather providers that do very specialized reports, like in ski countries, or water taxi services, or they might have their own private weather vendors?
Yeah, a lot of them do. So
Do you
anything,
share information or have any agreements with them or anything like
we,
that?
I mean, we share. So the government, our tax dollars are paying for this. And anyone have a guess, say, for the average taxpayer, how much you're paying for the National Weather Service in 1 year? Anybody have an idea? I'll give you a hint, it's a bargain. $5. $5 gets you everything you could want. And so all of this data that I talked about, it's freely available. So a lot of the commercial companies, what they do, and they're welcome to do this, they take the data, they package it, maybe make nice graphics, things like that. The online model sites are a great example of that if you've looked at those. They're taking freely shared data and packaging it and selling it. Good for them. But the private companies can take this data and tailor. They can do a lot more than we can do. So I can't go to, tell Blue Hills Ski Resort that, hey, it's going to be 22 degrees tonight. You can make snow. That we're protection of life and property and help with the economy. That's where we come in. So I can't provide that specialized service. A private company can, which is great, and it helps them make money. So they can provide a service that we can. In other words, they can make it more localized. So that's kind of how the system works. Yeah.
One more thing, because we do have NOAA weather radios, and you know why.
Yes,
my daughter's in the field.
because of your daughter.
Could you explain what those are to the public? Because it's really something that a lot of
Yeah.
people should know about and possess in terms
Yeah.
of emergency.
Yeah, so you could go, probably any electronic store would have them. It's a special frequency radio. It gives weather around the clock, but it's really used, you can set a tone alert if there's any severe weather warnings issued. So say we have, middle of the night and we've got bad thunderstorms coming through with wind damage. It'll alert you and wake you up and say, maybe you want to take cover in a lower floor or something like that. So they're used to alert for severe weather largely, but it's a great, great system to have. Before the internet years ago, a lot of people had them just for weather information. But now it's more for the smoke alarm in your house. Have a weather radio in your house too, just for safety. So electronic stores would have them or online. Amazon has them. But yeah, you're right. Not a lot of people have them anymore, but it's just a great safety net for severe weather and being notified. So, yeah.
I'm just wondering about tornadoes in New England. We don't seem to have a lot, and then the last couple of years it seemed like we had huge ones.
Yeah.
That they have in the Midwest, but they've been having smaller ones more frequently.
Yeah, so funny you should mention that because we actually started doing a lot of research on that. There's a couple of reasons why we have more tornadoes. First, we hear about them more. People would give us cell phone video. 10, 20 years ago, we weren't hearing about them. And also our radar too is a lot more advanced. It can actually detect, you've probably seen the debris signature on TV. We know now when one touches down, so that's one part of it. But we are seeing, I think, more. The ones here are, 95% of them are weak. They'll touch down for a couple minutes, go right back up. Usually don't, cause 60, 80 miles per hour. It's damaging, but over a very small area. Every once in a while we get the big ones, June 1st, 2011, the Worcester tornado. That's a 50, 60-year event for us. So we don't see those as much. But yeah, there are a lot more of these short-lived tornadoes. Last year was very active. Is it just a cycle? Maybe we're in a more active pattern? Yeah, but we're also warming. So warming, more moisture, more thunderstorms, more chances at a tornado. Also a stronger jet stream too. So, some of that has to do with the changing climate, I think. I don't know how much, but yeah, we've definitely seen a lot more. Like the one in Scituate, Rhode Island last year was a big one. That did quite a bit of damage, all the way up into North Attleboro. So, we do get them.
How come we don't have the big huge ones that they have in the plains?
It's a lot of it's a geography. We're not the plains where it's wide open. We don't have the Rockies right next door, which is a lot where the drier air can come in and help them. We're more we get ours in those tropical soupy air masses a lot of times where it's really, really sticky. Those days we'll get them. And just, yeah, like I said, the terrain will a lot of times break them up and things like that. We still get them, but usually not to the degree of that. June 1st, 2011 aside, which is certainly a good example of that. Yeah. Yeah, good question though. Steve?
Can you explain in storm prediction where the European model comes from, or who puts that together,
Yeah.
and then there's the American?
Yeah. So have you guys seen, you've probably seen TV, the European model, the American one, the GFS, right? So I'll tell you, everyone always says the European's the best, right? I hear that all the time. Well, I'll tell you, it stunk on this last storm this weekend. It was horrible. It had us getting a foot of snow. So it did, the American GFS actually did pretty well. So there's all around the world the different meteorological agencies. So the European Center, composed of all the various countries in Europe, has their model, and it's a very good model, no doubt about it. The United States has a model, it's a little bit different, and they're supposed to be different. We don't want them being exactly the same, right? The UK has their own model, Germany has one, so, but it's all freely shared, which is nice. Among there's international agreements that we share weather data, observations and forecasts. So we can get the data from the European Center, we can use that. We get Canadian data, we get the UK, pretty much, the Australians actually use our model, believe it or not, and the European. So they don't run their own. But yeah, there's a bunch, depending on the country or the kind of consortium that they run these models. There's all different versions. And the models are really just a bunch of math equations. That's all they are. They simulate, motion in the atmosphere, fluid dynamics, all good sorts of stuff I had to learn in college that I don't remember anymore. But again, the models are different for a reason. So you don't want them to be, if we were exactly like the European model, you'd get the same forecast. So you want them to be a little bit different. The one thing we're using today, have you got a sort of ensemble forecasting? This is kind of neat, yeah. So what you do is you take, say, our GFS model, right? We don't run it once, we run it 40 times. So we tweak maybe temperatures at the beginning, or we tweak the jet stream. We tweak something on each run so it's a little bit different. And then we get more of a probabilistic forecast. So we can say, well, where's the best chance of 6 inches of snow? Maybe I'll go back to my map of New England. So maybe where's the best chance? The ensemble, one model might say, oh, this is going to be where the heavy snow is. The ensemble could say, oh, that's kind of an outlier. The heavy snow is going to be back here. And we can use those probabilities to really message a storm in days in advance. It works really, really well. So each of these centers now, the European center is doing it, we're doing it. We have these ensemble forecasts, and you'll see a lot of probabilities a lot of time. It's just a better way of kind of ironing out that uncertainty a few days ahead. So we can really, instead of just saying, oh, it's going to snow here. Well, oh no, it shifted over here. Oh no, it's back over here. Because I'll see storms waffle all the time a few days in advance. How many of you have seen like online weather data? If you're looking at a storm, oh, it's a big hit. Well, if it's 4 days out and everything looks great, no. So usually it's going to change. So I know everybody tends to get excited on social media in those cases, but it's just the ensembles are a really good way of kind of getting different solutions from one model. So that's kind of what we've been using, where we're going in forecasting. So does that make sense? Yeah. Okay. Anyone else? Yeah.
Could you tell me the difference between partly sunny and partly cloudy?
Well, I always thought that partly sunny and mostly cloudy were the same thing. I always thought partly sunny and mostly cloudy were the same thing, right? If the sky is partly sunny, it has to be mostly cloudy. And the opposite, mostly sunny is partly cloudy. But I was told, no, that's wrong. I'm like, well, it can't be wrong. So honestly, I don't know. I mean, I always thought that partly sunny meant more clouds than sun, and partly cloudy was the sky was partially cloudy. So, but everyone seems to have their own interpretation.
Yeah.
So, yeah.
When I visited the National Weather Service, I actually asked that. I go, what's the difference between partly sunny, partly cloudy? Is it one meteorologist is an optimist and one is a pessimist? And they said, no, actually you can use partly cloudy because you can't say partly sunny at night.
Right. Well, that was the thing. We were always told, use the references to sun at the daytime. When when I started, we used to actually type the forecast out. Yeah. We don't do that anymore. But yeah, it was used to partly sunny in the day and partly cloudy at night.
That's a very good.
Yeah. 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 So, anyone else?
How about this obsession with weather forecasts, like it's going to rain today, and then they tell you it's going to rain 0.1 inches.
Yeah.
So everyone's like, oh, it's going to rain today. Well, don't you just call that drizzle in the old days?
Yeah, it's not that much. It's light rain. Yeah.
But people will seem to adjust their schedules because it's going to rain 0.1.
Right, which isn't that much. Yeah, yeah. Yeah, I mean, it's just a bunch, maybe people just don't understand really what that means. But yeah, no, I agree with you. I mean, if it's going to rain 1/10 of an inch, I'm not too worried about that. It's light, yeah, yeah. But I know a lot on TV, they'll show the maps now of here's the projection of rainfall totals. And, you know, okay, in this case, yeah, that's a good storm. But sometimes it's like, yeah, 0.02. It's like, okay, yeah. Yeah.
Yeah, could you speak a little to weather satellites and what they do?
Yeah, so they do a lot now. So we now have the latest satellites that went up, I think it went up in 2016, were the new GOES satellites. They're geostationary, so one is kind of orbit checking the east, one's in the west of the US. They have a lot of advanced instruments on them now, so they can sense moisture all the way down, temperature all the way down. Anybody remember the old balloon soundings that so we still have the station in Chatham that's being reestablished because the station was going to fall in the ocean. I don't know if you heard about that. So out in Monomoy, where the station was, the cliffs were eroding. So about 4 years ago, we had to actually close the station because the building was going to fall in the sea. So they did. They demolished it. We're in the process of reestablishing a balloon site. But years ago, the balloons were what went into the models. That was the thing. You know, your balloons had to go up twice per day. At noon and midnight Greenwich Mean Time around the world, the balloons, they go up twice per day. We use them now mostly for observations, but back in the day, that was what entered the models, and they were critical. Now, they only account for about 5% of the data that goes in the models. It's all satellite. So the satellites are just tremendous. We used to have scans, images come in by fax every 30 minutes. Then when we got to computers, it was about every 5 minutes. Now we get routine 5-minute imagery. When there's significant weather going on, we can request a rapid scan 1-minute imagery from a satellite, zoomed up like over the Northeast. It's amazing. So whenever there's a big weather event, we get the rapid scan mode going. So it's just, you know, it's like an old, you know, Magnavox TV from the 1950s versus your HD TV today. It's that dramatic. It really is.